we want to now look at solving quadratic equations by factoring. In class, we talked about there's four different possible ways you can look at to solve quadratic equations. Once again, a quadratic equation means you have your variable squared. That is what makes it a quadratic equation. If you don't have any exponents on your variables, we call those linear equations. So now we're looking at the case where we have the variable squared, and that's called a quadratic equation. And one of the ways that we can possibly look at to solve these equations is by factoring. Now let's go ahead, and I'm going to work three problems. And in class, I gave you the steps to go through, so I'm not going to rewrite them, but I will refer to them as we do these examples. So the first example is pretty straightforward. X squared minus 3x minus 28 equals 0. Okay, just as a quick reminder, whenever you're going to try and solve a quadratic equation by factoring, the first step is to get rid of all parentheses if you have any. And then the second step is to get everything on one side so that one side is 0. Now, as it turns out, this problem we were given, there are no parentheses and everything is already on one side. So in this case, now we have to factor the left-hand side. And now we go back to our rules of factoring. First thing we check is for a GCF. There is no GCF. And now we see there are three terms. So it's a trinomial, so we're going to do product sum. So I go off to the side, and I see that my product is going to be 1 times negative 28. So it's negative 28. And my sum is the coefficient of the middle term, and it's negative 3. So once again, I'm trying to find two numbers that you can multiply together that equals negative 28. But when you turn around and add the same two numbers, they equal negative 3. And as it turns out, once you do these enough, you can oftentimes pretty quickly begin to see what the factors are. And I believe it should be negative 7 and 4. Now, a quick review of factoring for this trinomial. Since there was no coefficient for the squared term, I can now go ahead and factor the trinomial. X minus 7 times x plus 4, and that equals 0. Now the whole key to why factoring is useful in this case, if you look at this initial equation, we have no way of solving for x using our normal rules like for a linear equation by moving things from side to side. However, if we factor, here's what we end up with. We're multiplying these two parentheses together. Now they have to equal 0. When you multiply these two parentheses together and for it to equal 0, one of the parentheses has to be 0. So whatever value would cause the first parenthesis to be 0, a lot of times I write this, or whatever value of x would cause the second parenthesis to be 0, those are both going to be solutions. So in this case, we can just simply look at it, and if we look at the first parenthesis, what value of x would cause this first parenthesis to be 0? X equals 7. And now I look at the second parenthesis, and I say what value of x would cause that parenthesis to be 0? And it's minus 4. Now for this kind of problem, you can always go and check your solution. You can plug 7 in to the original equation, make sure it works, and you can plug minus 4 in. Now you are not required to do that. It's always a good idea on your test, when you're totally finished with the test, if you want to go back and check your solutions. But you don't have to. In a few minutes, The third problem we're going to do today is one where we have to actually check our solution, and you'll see why in a few minutes. So there's the solution for this one. Now, the second problem. 2x times 4x plus 15 equals 27. All right. It may not initially look like a quadratic equation, but as soon as I multiply out the parentheses, you can see what happens. So I have to use the distributive property and multiply the 2x by 4x, which is 8x squared, and then the 2x times 15 plus 30x equals 27. Now to solve a quadratic equation by factoring, we have to get everything on one side. So I'll subtract 27 from both sides, and I end up with this trinomial. Okay, so now I need to factor the trinomial. There is no GCF. Since I have three terms, we're going to use product sum. Now, this is a little bit ugly, and maybe this is a good problem to work because you can see what you can do to possibly try and factor trinomials with larger numbers. Because the product is going to be 8 times negative 27. So that's like negative, I should probably get my calculator, which I forgot my calculator. I think it's 160 plus 56, I think it's negative 216. And the sum is going to be 30. So now, I'm trying to find two numbers that I can multiply together that equals negative 216, but when I add them together equals 30. Now the first thing I realize is to get a negative product, I'm going to have to multiply a positive number times a negative number, and the positive number is going to be the larger number, because when I add them together, I end up with a positive sum. Now, for most of us, in our heads, it's hard to find two numbers that multiply together equal 216. You can grab your calculator and just start punching in numbers and do trial and error. But let me show you one method that sometimes works. Well, it always works, but it's a little bit of work. So here we're going to go down a side road, and here's how you try and factor trinomials when your numbers are pretty big. I'm going to take the 216 and I'm going to break it up into its prime factors. That means I'm going to take the 216 and I'm going to first think of two numbers I can multiply together to equal 216. And I'll just pick a straightforward one, 2 times 108. And what I do now is I keep breaking up these numbers until I can't split them up anymore. For instance, 108 is 2 times 54. And then 54 is 2 times 27. 27 is 3 times 9. And 9 is 3 times 3. Now what I'm going to do is I'm going to go collect all the numbers at the bottom of the branches, and this becomes what I call the prime factorization of 216. So I have 2 times 2 times 2 times 3 times 3 times 3. If you multiply those 6 numbers out, it should equal 216. Now here's what I'm going to do. I'm going to start breaking, I've got 6 numbers here. I'm going to break them up into 2 groups and then multiply those together and see if they would happen to work for my product sum. Let me show you what I'm talking about. Let's just say my first group, I'm going to just take the 2's. So 2 times 2 times 2 is 8. So therefore the second group would be 3 times 3 times 3, which is 27. I'm going to see if those two numbers will work for my product sum, because 27 times 8 equals 216. So in this case, the 27 is going to be positive, the 8 is going to be negative. The sum for these two, if I make the 8 negative, so 27 minus 8, 19. That's not the correct sum. So now I go back to my 6 numbers and I break it up into 2 different groups. Maybe I'll just try 2 times 2, which is 4, and then I'll put the rest of the numbers in the second group. 2 times 3 times 3 times 3. This is going to be 9. Now if I make the 4 negative and the 54 positive add together, that's a sum of 50. Well, that's not what I want either. So now, yeah, this is sort of trial and error, but you keep trying out. How about we take maybe 1, 2, and a 3. Don't know if this is working out. That's 6. So I have 2 times 2 times 3 times 3. That's 4 times 9. So now, 36 minus 6. And there we have it. Our sum is now 30, which is what we want. So now I realize that my factors are going to be 36 and negative 6. All right, that was pretty painful. But unfortunately, sometimes that's what you have to do when you factor trinomials with large coefficients. So now, let me continue to work this problem out on another sheet of paper. So now I go back to my original trinomial, which is 8x squared plus 30x minus 27 equals 0. I now know my factors are 36 and minus 6, and I notice since I have the number in front of the square term, I have to write the first term and the last term, and then I'm going to split up the middle term. How about I do it, let me just put the minus 6x here and the plus 36x over here. And now I do my factor by grouping. The GCF here is going to be 2x, 4x minus 3. The GCF here is going to be 9, 4x minus 3. And now since my parentheses are the same, I factor out the whole parenthesis. So now I have factored that trinomial into 4x minus 3 times 2x plus 9. So now I simply have to take each parenthesis and figure out what x would have to be for those to be 0. Since it's not obvious by looking at it, I just take the first parenthesis and set it equal to 0 and solve for x. So add 3 to both sides. And then x would be 3/4. The second parenthesis, 2x plus 9, I set it equal to 0. Subtract 9 from both sides. 2x equals negative 9. Divide both sides by 2. And x is negative 9/2. So now my two solutions are negative 9/2 and 3/4. It would be pretty painful, but I could plug those back in to the original equation and see that they do, in fact, they are solutions. Now I do want to work a third problem, but because the second problem took so long, I'll work out the third problem on a separate video.